Hi, I'm Patty from Amplify Science. I'm going to lead you through this unit orientation video for the fourth grade unit, Earth's Features. In Earth's Features, students take on the role of geologists to help the director of Desert Rocks National Park explain how and when a particular fossil formed and how it came to be in its current location. Students find a rocky outcrop in Desert Rocks National Park that has rock layers and a fossil in it. They work to figure out what the environment of the park was like in the past and why it has so many visible rock layers. As they work through the 4 chapters, they gather evidence from multiple sources by doing, talking, reading, writing, and visualizing. Their explanations become more complex over time as they construct understanding about how sedimentary rock forms when sediment piles up and hardens over time. They learn that fossils can form in the rock if organisms are buried in the sediment. Then they discover that different sedimentary rock forms in different environments and that the lowest layer of sedimentary rock formed first. Younger layers form on top. This unit is an argumentation unit. In their role of geologists, students help develop skills with the science and engineering practices, developing and using models, and engaging in argument from evidence. Students obtain information from text and use physical and digital models to construct understanding of how rock forms and erodes, how rock layers form, and how to use rock layers to infer the environmental changes that have happened in a place. They apply their new understanding to engage in oral and written argumentation about the geologic history of the Desert Rocks National Park. The focal cross-cutting concept in this unit is stability and change, with opportunities to address the cross-cutting concepts, patterns, and cause and effect as well. In their role as geologists, they look for changes over time in fossils and sedimentary rock, changes in the environment, and discover how the order of rock layers in a place can help them infer environmental changes that happened in the past. Every Amplify Science elementary unit also includes a focal sense-making strategy, which students leverage as they read and also during investigations. This unit's sense-making strategy is making inferences. Students make inferences about what they think has caused different rock formations to erode, and they then explore erosion in text and in the simulation. The main writing genre is scientific argument. Students use information from class models and the simulation to write arguments about the factors that can cause more erosion or less erosion in a canyon. So that's it for the overview. Now I'll talk you through what happens throughout the unit, how students build from their prior knowledge to get to a complex causal explanation of the anchor phenomenon. To do this, I'll summarize the key ideas students figure out in each chapter and how they use these ideas to explain the anchor phenomenon piece by piece. For each chapter, I'll highlight 1 or 2 key evidence sources students use. But remember, in every chapter and indeed every lesson, students gather evidence multimodally from many different sources. In Chapter 1, students investigate the question, how did the fossil get inside the rocky outcrop? They learn that sedimentary rock forms when sediment piles up and hardens over time. Fossils can form in the rock if organisms are buried in the sediment. Key evidence sources in this chapter include discussing initial ideas about rocks and fossils, getting more evidence from reading clues from the past, and observing fossils. At the end of Chapter 1, students return and apply these ideas to the anchor phenomenon. They explain that the fossil is the preserved remains of an organism that lived a long time ago. The fossil formed when the organism died and sediment sank through the water and completely covered its body. More and more sediment continued to build up over the body. As more sediment landed on top, it compacted the sediment that was already there. That sediment cemented and became rock. This process gradually made a thicker and thicker rock layer. Parts of the organism became preserved in this rock layer. In Chapter 2, students work to find an answer to the question, what was the environment of Desert Rocks National Park like in the past? In this chapter, students learn that different sedimentary rock forms in different environments. Students gain information from evaluating text, comparing two types of sedimentary rocks, and using the sim to investigate how rocks form in different environments and create different rock layers. At the end of Chapter 2, students are able to explain that the environment at Desert Rocks National Park was a floodplain when the lower rock layer was formed and a deep ocean when the upper rock layer was formed. The lower layer is made of siltstone and contains a lepidodendron fossil. Siltstone can form in floodplains. Lepidodendron lived in watery areas with a lot of plants. Floodplains have a lot of water and a lot of plants, so the environment must have been a floodplain when the lower layer was formed. The upper layer of the rocky outcrop is made of mudstone. A Mosasaurus fossil and a Mortoniceros fossil were found in this rock layer. Mudstone can form in a deep ocean. Mosasaurus was a large animal that swam in water. Mortoniceros used to eat plankton, which live in deep water. The environment must have been a deep ocean when the upper rock layer formed. In Chapter 3, students investigate the question, what is the order of the past environments in Desert Rock National Park? And they find out that the lowest layer of sedimentary rock formed first and younger layers formed on top. Students collect and process evidence as they develop a paper pile model of sedimentary rock layers using colored paper. They reflect on their observations and then search for evidence about the order of rock layers in the Fossil Hunter's Handbook. At the end of Chapter 3, students are able to explain that the siltstone layer is below the mudstone layer, which is below the shale layer. Lower rock layers form first, and new rock layers form on top of them. So lower rock layers are older than the layers above them. This means that the siltstone layer formed first, and then the mudstone layer, and then the shale layer. This also means that the environment was a floodplain first, then a deep ocean, and then a shallow ocean. In Chapter 4, students answer the question, why did more rock layers get exposed in Desert Canyon than Keller's Canyon? Experiences in this chapter lead students to discover that rocks can be broken down and eroded by things in the environment, such as wind, water, plants, and ice. The speed of water and the amount of time it flows affect how much rock it erodes in a canyon. Students collect evidence and compare data from the SIM and use the stream table erosion model to plan and carry out investigations about how the river's speed and the length of time affect erosion. Then they use an evidence circles routine to prepare to write an argument about the Chapter 4 question. By the end of Chapter 4, students explain that more rock layers got exposed in Desert Rocks Canyon because the river that flows in Desert Rocks Canyon is faster and has been there longer than the river in Keller's Canyon. Rock can be broken down by water, and the longer a river flows, the more rock it can erode. Also, a faster river can erode more rock. This means that the river in Desert Rocks Canyon eroded more rock and exposed more rock layers because it's been flowing over the rock longer and because the river is faster. I hope you're feeling excited to start teaching this unit. In addition to the resources on the Amplify platform, you can check out the at-home videos and the at-home units to help you teach the unit remotely. The at-home unit will be out January 17th and the Spanish at-home unit on February 1. You can use any combination of these resources to engage your students in figuring out about Earth's features. Please let me know how I can help you plan for instruction. I'm Patty Works, and my email address is pworks@amplify.com. Thank you so much for joining me.